Hey everyone, in this video I want to be talking about how to estimate construction costs. So whether you're a construction project manager, an engineer, a quantity surveyor or work in the industry, estimating is a critical skill. And so in this video I'm going to talk to you about what estimating is, when you use it, and then how to estimate construction costs, and then we'll finish off by going through a detailed worked example. So just a quick overview of the presentation. I'll go through who this is for and then as well who I am and a bit about my background. We'll talk about when construction estimating is used in the life cycle of a construction project. We'll talk about the different types of construction costs and why it's important to understand them when you're preparing an estimate. We'll then go through the estimating process, so I'll explain step by step how you actually estimate construction costs. Then I'll finish off by going through a detailed worked example for a real project. So just a little bit about me before we get started. My name's Tim. I'm a senior project engineer with almost 10 years experience in the industry. I've worked on a variety of renewable energy, construction, infrastructure, road and rail projects, and I've mainly worked at large tier 1 contractors. And I'm also a project management professional and a chartered professional engineer in electrical engineering and project management. So these courses are targeted at construction project engineers, managers, estimators, quantity surveyors who want to accelerate and grow their career by mastering the fundamentals. So far, we've helped over 20,000 students, and 94% of students we've surveyed said these courses, mastering the fundamentals, helped accelerate and grow their careers. Let's start by talking about when estimating is used in the life cycle of a construction project. So we've got our feasibility and concept development stage. So this is the initial stage of a project where the concept's developed, where people work out whether it's worthwhile proceeding with a project. Estimating here is used to basically determine if the value that's delivered by a project is going to be worth the cost. So if you take the example of a solar farm, if someone wants to work out whether it's worth building, it's going to come down to a value and cost equation. Is the value delivered by the solar farm, so the amount of electricity it produces and how much you can sell it for, is that going to be worth more than the initial construction and finance cost? So estimating is critical here to accurately project how much something's going to cost. Then we've got the tendering and pre-contracts phase. So this is after a project's been developed, we've decided to proceed with it. Then a project developer is going to try and engage a general contractor or EPC contractor to deliver the project for them. They'll typically do this under a lump sum fixed fee contract. So for the general contractor to quote this job and to tell the developer how much it's going to cost, they're going to need to perform a detailed cost estimate and establish how much they think it's going to cost to deliver. Then during the design stage, so when the design for the project's being developed, estimating is also going to be used to manage design development costs. And this will be when different design decisions are made, when different options are explored. Cost is going to be an important input into this. So for example, if we could use underground conduits or above ground cable tray, cost would be a key decider in which design solution we use. So estimating is actually used a lot during the design development stage of projects. And then finally, during project execution. So once the design develops, once the contract is chosen, once the construction phase starts, estimating is going to be used a lot during the construction phase to price variations. So when there's a change in scope from the original requirements and the general contractor submits a variation to the project developer, estimating is going to be used there to price the variation. Both the general contractor and the project developer are going to need to use estimating to forecast completion costs. So that's an important part of construction cost control. And then finally, it's also going to be used for value engineering. So when project managers, project engineers need to make decisions, they'll use the estimating the cost of different alternatives as an important input into this decision-making process. Now that we understand when estimating is used, let's talk about the different types of construction costs. Now, this is important to understand because to produce an estimate, you're going to be individually calculating all of these different costs. So you've got to actually understand what an estimate consists of to be able to accurately produce one. Now, we can break construction costs down into two pieces. We've got our direct costs, which are the costs it actually takes to physically complete the construction works. Then we've got our indirect costs. So our indirect costs are the costs to supervise and manage the construction works. So direct costs are the costs it takes to physically complete the works, and indirect costs are the costs it takes to manage the work. So we're thinking direct costs, we're thinking the cost of pouring a concrete foundation. So the labor to pour the foundation, maybe we need a concrete pump to place the concrete, and then the actual cost of the materials themselves. So those are the direct costs, and then the indirect costs would be the project manager or engineer that's overseeing the work, the site supervisors, the lunchroom facilities, the office facilities. So all of these other ongoing costs that occurred to deliver the project. Our direct costs we can break down into 4 parts. Now, there'll be other types, but these are the main types you're going to see on a construction project. You'll have your subcontract costs. So these are the costs of engaging external subcontractors to complete work. You'll have your plant costs. So there's the cost of plants, so things like concrete pumps, vehicles, trucks, that sort of excavators, those sorts of things. For your labor costs, so these are the costs of labor that you directly hire to complete tasks. So for concrete foundation, you'll have form workers, steel fixers, concreters to place the concrete. So that's your labor costs. And then you've got your materials costs. So your materials costs are things like permanent or temporary materials required to complete the project. So concrete, steel reinforcement, if we're doing earthworks, any imported quarry material for electrical works, electrical cables, conduits, and steel beams for a steel structure. So those are all material costs. Now, indirect costs we can break up into 2 parts. We've got our reoccurring indirect costs and we've got our one-off indirect costs. So one-off indirect costs are things like hiring project management staff, hiring site supervisors, setting up crib facilities, setting up office facilities, or costs of permits. So those are all one-off indirect costs. Then we've got our reoccurring indirect costs. So our reoccurring indirect costs are things like staff salaries, the hire of any cribbing facilities or hire of toilet blocks if we need them. Those are all reoccurring indirect costs. Now, the reason it's important to distinguish reoccurring versus non-reoccurring costs is because reoccurring costs are going to be driven by the project schedule. So the longer the project takes to complete, the more these costs are going to increase. When we sum our direct costs and indirect costs, we get our total project costs. So this is the amount we foresee we will need to spend to deliver the project. That's just an accurate estimate of what we think it's going to cost to do the work. On top of this, we need to add on risk and opportunity. So projects are temporary endeavors, they're unique. Projects always involve risk. Things aren't going to play out exactly as how you anticipate them. So on top of our costs, we then need to add on risk and opportunity. And finally, say for a contractor, we need to add on a profit margin. So if we're bidding, tendering to do work, we'd get our costs, add on our risk and opportunity, and finally mark up these costs with a profit margin to prepare a quote to submit to do works. Now we understand the different types of construction costs. So what are the pieces that fit together to make an estimate? Let's step through the process of how you actually develop a construction estimate. The first one is always going to be to define and understand project scope. So this means you'll read the drawings and specifications, any project documentation. Maybe there's a project specification that defines exactly what we're going to be doing. That's the first thing you're going to do. You're just going to understand project scope. And then using this, we're going to create a work breakdown structure. Now, work breakdown structure is a hierarchical decomposition of the project scope that basically helps us understand and define the project in detail. We'll be taking the overall scope of the project and defining and breaking that down into component pieces. The next thing we need to do is we need to estimate our direct costs. So our direct costs, as I've said before, are the cost to physically complete the construction works. To establish our direct costs, we'll need to come up with a methodology. So we'll need to work out how we're going to complete the work. We'll need to allocate resources to these tasks. So work out what resources we need. Are we going to use subcontractors? Are we going to self-perform the works? How exactly are we going to do the works and what resources are we going to need? And then we'll need to allocate costs to each of these resources. Once we've worked out our direct costs, then we can work out our indirect costs. Now, steps 2 and 3, you can do iteratively. You don't necessarily need to do your direct cost. You don't need to necessarily do your indirect costs before your direct cost. However, when you calculate your direct costs, it helps you understand your indirect costs. So by working out how much labor you're going to need on site, then you can more accurately work out what level of supervision and management you're going to need. That's why it always makes sense to do your direct costs before your indirect costs. However, they can occur iteratively. So to work out our indirect costs, we can work out our non-recurring one-off costs. So things like permits and applications, these sorts of things. Then we need to work out our reoccurring costs. So these are the ongoing higher cost staff salaries. And to calculate them, we're going to need a project schedule. Then once we've calculated all our project costs, we can apply our margin and overheads to this to get our prepared cost estimate. Okay, so now we understand the process. I want to quickly go through a worked example just using Microsoft Excel and a template that I've created. If you want to get access to that template, just click on the link in the description. But we'll work through how to estimate the costs of constructing concrete foundations on a new building. The scope we've been requested to price. So let's imagine we're a subcontractor pricing this for a general contractor who's managing the overall construction of the warehouse, and they've asked us to price just the supply and install of the foundations. Specifically, they've asked us to include survey and set out, excavation, the supply and install of the concrete, and any project management and supervision we need. They're going to provide any cribbing facilities, any toilets we need, but we just need to complete the physical construction works. So let's start off by going through this worked example, and you'll see how these steps fit together. Okay, so for this project, we're going to need to work out the costs of preparing the concrete slab and the footings for this proposed warehouse. So the first thing I like to do when I get a set of drawings is simply to have a look at the overview and then just to scroll through them and get an idea in my mind of what we're building and what we're going to be pricing. So you can see this just gives, and I'm just doing this in Bluebeam if anyone's wondering what the PDF software is. And in this, it just shows us an overview of a warehouse, and you can see all these detailed concrete blocks which form the footings. Next, we've got some general notes details. So there's concrete notes, footing details. There's grades of the concrete. It's probably the only stuff that's going to be relevant for us. Then we've got this drawing which actually gives us a footing plan. So it shows us all the different footings. The F numbers refer to the footing schedule. And then, so we've got all our footings. And then you can also see here that the top of the concrete footings is all at a height of 30.95. And the finished floor level is at 31.25. So that tells us the height of the thickness of the slab on top of the footings is going to be the difference between these two. So about 300 mil. So 300 mil is going to be the width of the slab. Gives us these heights. We've got a detailed set of drawings for this building and footing details, and there's an office footing schedule, so those footings seem to be quite a bit bigger. And they also tell us the reinforcement details, so that just mass concrete, those are all mesh. And this next drawing is got slab details, so you can see in this slab that there's a membrane under the slab. It looks like a layer of blinding. There's SL92 mesh top and bottom, and it also gives us all the dimensions of the different joints. So 160 mil thick steel fiber reinforced slab, 40 MPa, and a membrane, and it's on a compacted pad. It's actually not, so before I was saying there's blinding, but in this case they're just referring to the slab just sits on a concrete pad. So there's some detailed version of the footings, and you can see there's all these steel columns and piers that fix to this. and there's also blockouts around the piers. So this is when we start to refine the project scope and go through this in detail. This will be important when we create our work breakdown structure, but also document our assumptions. Now, assumptions are important to capture because we need to clearly define what we're pricing. So if we're submitting a quote to a client, we got to clearly show them what we've priced, what we haven't. You can see all this, just additional detail for the slabs, and you can also see all these slab blockouts, and then these steel beams are drilled into the concrete footings. So let's just quickly scroll through the rest of them. This is some detail for the office slab. And yeah, then there's all details for the structures of the building, which isn't relevant to us. So the next thing we need to do is actually create our work breakdown structure. So work breakdown structure. Now you can just do this in the pricing model, but I like to do it in a separate tab. And then we're going to need to also know our quantities. So what are the quantities of the key tasks that we're going to complete? So I also like to write down any assumptions so we can explain what we're going to price. So let's work through the steps of what we're going to be pricing. First off, we've got the detailed excavation. We've then got formwork. So this will be formwork for the perimeter and blockouts. Then we're going to need to do steel fixing, so the placement of all the mesh. We're going to need to do concrete placement. We're going to need to then do saw cutting. So let's put these into our work breakdown structure. We've got detailed excavation, formwork, steel fixing, concrete placement, and saw cutting. And some of these we're going to have to break down a little bit more. So detailed excavation, we just need the number of footings, because we're going to assume, we're also going to put in our assumptions that bulk earthworks done by others. Now this assumption just pretty much means that we're going to assume that when we start the works, somebody else has prepped all the ground up to the underside of the slab. So all we're going to have to do is go and dig out the footings. So bulk earthworks done by others up to underside of the slab. So we're just going to work out the number of footings. Well, formwork, we'll get perimeter formwork, and we need to know the number of blockouts. Then for the steel fixing, because it's all mesh, we'll need to know area of mesh. The concrete placement, we'll need to know volume of concrete. The footings and volume of concrete. The slab, because remember they're going to be done in 2 steps. And the saw cutting, we're going to need linear meters of saw cutting. So let's then note down what each of these is going to be. So quantity, number of footings. I'm going to actually have to, I've just moved this here so it's not messy. I'm actually going to need to know, we're just going to need to know total number of footings. So I'm going to exclude this office block to make this just really simply. And I mean, obviously we can go back and add the detail later, but we're basically going to need to know each of these different types of footings. So F1, F2, F3. So just go through the drawings. And I'll look at the simplest way to do this. So we've got, what's the easiest way to count these up? Go tools, measure, count. And let's start with this. Just So these footings are all incredibly similar sizes. So we could make it really easy for ourselves and just assume they're going to be all the same size. So what's the biggest one? 2, 3, F7, F8, F9. Now, this is the wrong way to do it, but for the interests, keeping it easy, we're just going to assume they're all F7. 2100 by 600. And let's just quickly work out how many footings there are. So I'm just using the Bluebeam count function, but you can obviously do it however you want. So the Bluebeam count function, you just basically allows you to go through and click all the items you want to count. Now, obviously, if we're doing this estimate properly, I should have gone and calculated all of the individual footings, and I should have looked at all the different sizes and done a schedule, but I'm being lazy. So then what does that tell us? So once we've done that, ticked them all, there's 56 footings. Again, I've just going to assume they're all F7, which is 100% wrong, but I'm just making it easy for myself. Then that also tells us the number of formwork blockouts we're going to need. I'm going to actually break still fix into area of mesh footings and area of mesh slab.
The couple.
Break this up a little bit. So 56 footings, assumed F7, which is 2100 by 2100 by 600. So that's also going to tell us the volume of concrete in footings. It's just going to be 56 times 2.1 times 2.1 times 0.6. It's going to be meters cubed. It's a lot of concrete, and the volume of the slab, so the perimeter of the edge of the slab. So this will be, what do we say the depth of the slab was? Actually, that's another important assumption I should document. Assume footings can be earth formed. So that means we're not going to put formwork around the blocks. We're simply, if you imagine, we're just going to excavate and place the concrete in the hole. We're not going to form this up. So that's earth forming. So just note that down as an assumption. So the depth of the slab is, actually that was on another drawing, the depth of the slab. The fiber slab is 160 mil. Slab is 160 mil, so that's going to tell us the perimeter formwork is going to be 160 mil deep by the area. Now, okay, so the scale on this is 1 to 250. So I'll just quickly go tools, measure, set scale, custom, 1 centimeter equals 2.5 meters. And I just want to measure, what's the length of that? 85 meters. That edge is 157 meters. So this is a massive slab, and it's 80 meters by 150 meters. So then the perimeter formwork is also going to be 0.16 meters deep by 80 by 150. It's also going to capture the length. The reason this is because if you use a per meter squared rate for formwork for labor, it's going to be wrong, as if you were doing a wall. So we should actually get the length of perimeter formwork, which is going to be 80 by 2 plus 150 by 2. So more likely that we'll be using a linear meter production rate. So we need to know area of mesh in the footings. So we just quickly look at our mesh drawing. So it's 2100 by 2100 and there's SL81 top and bottom. So that's going to be SL81 total area of mesh. Because remember there's top and bottom, so we're just doing that. So 56 times 2.1 times 2.1, that's the area, times 2. Because there's a layer of top and bottom. And then at the slab, I think the slab was SL91. Is that, I'll just double check the Rio in the slab. Where is that?
And we've got it.
So SL92, it's just one layer on the top. So it's going to be 80 by 150 meters squared. Should also note, as part of our excavation, that we have to put in that supply and install vapor barrier. Then be 80 by 150 and it's going to be meters squared. So that's putting in this barrier at the membrane on the underside of the slab. What other quantities do we need? So the volume in the slab is going to be the area of the slab by the depth, which is 160. So actually look at this. This is a ginormous warehouse. It's 150 meters by 85 meters, which is huge. And then that volume of concrete, correct? So the area in meters squared is 80 by 150, and then depth. It's always 2,000 meters cubed of concrete, which is ginormous. And then we've also got to get the lengths of saw cutting. So we just use, so let's measure how many saw cut joints there are. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8 horizontal ones, and 1, 2, and I'll just write that down so I don't forget. 8 vertical. 1, 2, 3, 4, 5, 6 horizontal. Remember, I'm ignoring the office spot, which is wrong, but I'm just trying to make this easy. 8 horizontal, 6 vertical. It's going to be 8 by 80 plus 6 by 150. And then there's also those dowel joints. If you were to just quickly tally up those. So 1, 2, 3, 4 horizontal, and 1, 2 vertical. So 4 vertical, 2 horizontal. So that is going to be equals 4 by 80 plus 2 by 150. So that's 620 meters. Now, those dowel joints are also going to need, so construction joints, they're call them the construction joints. They're also all going to need formwork. So it's going to be 620 meters of formwork for those joints. And then if we look at where these dowels are, I'll just get another color. You can see So there's one there. There's one here. There's one here. There's one here. One here. Just ignore the office space. And one here. So they can see the slab is broken up into 12 different sections, which each would be about 120 meters cubed, which actually sounds about right. All right, so now I've got these quantities. Let's now turn these into an estimate. All right, so I'm going to just move all this information across into the pricing line. So we've got detailed excavation, and we've got footings and supply and install. Vapor barrier, what do we call that? Vapor barrier, vapor barrier, footings, excavation, footings. Now, I'm going to just be making assumptions about resources and everything, but in practice, I'll be making assumptions about things like resource rates, but in practice, you should be engaging the market, engaging suppliers to get these, or for example, resource requirements, consulting with experts. But I'm not going to do that. I'm just going to make some very basic assumptions in the interest of time. So formwork, how do we break formwork up? We'll get perimeter. Now the way I use this spreadsheet is just copy and paste to add new lines. Perimeter, so that's the formwork for the perimeter, and the construction joints and blockouts. Then you got steel fixing, and you got steel fixing for the slab, steel fixing of footings, and saw cutting. Add another line because I'll do one for the saw. I'll rename this construction joints. Saw cutting dowels. So formwork, supply, install and strip formwork. Resources is going to be supply of LVLs, so the boards, and labor to install, bills plus consumables, labor to install. The footings, we need, say, 6-ton excavator, labourer, operator, but no materials. So I'm actually going to qualify that material removed from excavation to be left on site. The vapor barrier will be labour, so the supply and labour to install. Construction joints formwork is just going to be the exact same. And the blockouts is going to be supply of LVLs and labour to install. The slabs is going to be supply and install Rio. B, supply of mesh and labour to install. Supply of mesh and labour to install. Construction joints is going to be saw cutting subcontractor. Saw cutting. And the dowels is going to be supply of dowels, labour to install. Okay, so now this spreadsheet is got some errors because I'm referencing things that don't exist because I've deleted everything from it. However, so if we just start pricing the first thing, so we need a 6-ton excavator and a labourer and operator. We've got 56 to do. So we just make a high level assumption it's going to be 4 hours per footing. So what labour are we going to need? We're going to need, so we say a labourer, $25 an hour, and then we also need an operator that is on $30 an hour. We're using an on-costing percentage. Let's just come up with some basics. So say 2% for payroll tax, 2% for workers' compensation, 2% for insurance. Sick leave is usually 10 days per annum, so 2 weeks. So it'll be, say, 10 divided by 2 divided by 50, so 4%. Annual leave is 4 weeks, so 4 weeks out of 50. Public holidays is 2 weeks. Training and RDOs, we say, let's just assume 1 week. And again, you could do more science behind all this stuff, but in practice, these are just ballpark numbers that work out. So they've got $25 an hour gives us, and we're assuming a 10-hour shift, so they do 2 hours of overtime, $38 an hour. So we'll call this crew type 1, and it's going to be we're just going to make it up with the labourer and the operator. It's going to be $75 an hour, labourer plus operator, so $750 a shift. And we say, then put this in our pricing model. So crew type 1, then just call that, sorry, that was meant to be civil crew. That one $75 an hour, and we need them for 4 hours per footing. So it's $300 of labour per footing. And we need, so plant, we need an 8-ton excavator. So we'll assume we'll dry hire this to make it easy. Give the code, sorry, we said 6-ton, didn't we? We need a 6-ton excavator. We assume we dry hire that at $800 per day. And that includes fuel. So I'm just going to put this as 6-ton. Alright, so we're just using a subcontract rate, and we'll just copy it into this table. So we've got a 6-ton excavator at an hourly rate of $80 an hour. I'll just manually set that because we haven't done the build up of owned plant. So that gives us $80, and again, so 4 hours per footing. That gives us a plant cost per footing of $320. Then what materials do we need? We don't need anything. We don't need any materials. And subcontracts, there's no subcontract costs. So that gives us 56 footings. That's $622 a footing, so 300 plus 320 gives us $34,000 to do all the footings. Now let's do the same for the vapor barrier. So we need 12,000 meters squared of vapor barrier, and we'll just say we just need a labourer to do this. So we'll just call this crew type 2 is just a labourer, and their hourly rate is just going to be their on-costed hourly rate is going to be $34 an hour. So we'll make this crew type 2, $34 an hour. They don't need any plants. Delete all that. The only thing they're going to need is material. So if, say we went to the market and got quotes for vapor barrier, call this vapor barrier, and we say it is $5 per meter squared. Just fix that up. And we just call this VP. Just copy this formula. Quantity we're going to need is 12,000. Sorry, the quantity we're going to need is 1. We need 1 per meter squared. So $5. It's going to be $4 million. that rate must be completely wrong. I don't think there's any way vapor. Say 20 cents per meter squared. That's probably a more realistic number. What does that give us?
To get that fight. The being lightened in it is scary. Water.
Sorry, the hourly rates here. So if we say someone does 50 meters squared an hour, so I'm assuming 50 meters squared per hour. So per meter squared, they use 1/50th. So it gives us a unit rate of 89 cents per meter squared, so 10,000 meters. And I'll just fix up this, sorry. Like that. There you go, $45,000. Now, for the formwork, what do we need? Supply, install, and strip the formwork. Supply the LVLs. So we start off with the labour. Again, formwork is just going to be a labourer putting it in. So that's crew type 2. And what are we going to say? The unit is per metre. We use the linear meters. So formwork is 1920 meters. That's wrong. 1920 meters. What was the other one? 620 for the construction joints and 56 walkouts. So if we say they said supply, install, and strip, someone would do 10 meters per hour. So 5 meters per hour to install, 5 meters to strip. So 10 meters per hour is 0.1 hours. So 10 meters per hour means each meter takes us 0.1 of an hour. Just quickly, so you're going to need no plant for that. You need no materials. We're going to need LVLs. So just set up a material code for LVL. LVL boards for formwork. And here you could just write based on supplier quote. Based on supplier quote. Sorry. Keep hitting the tab. It's $5 per. So they're $5 per meter, and then what does that give us total? So I haven't deleted the subcontract costs. Doing it at $3.40 a meter, 6,600. Let's assume we're going to need the exact same resourcing and labour productivities. And LVL is 1 per metre. We're going to use the exact same resourcing and productivities for the next one. Construction joints, that same rate with... And I'm just going to delete the subcontract costs. It's that same rate of $8.40 a metre, 16,000, and the final is the blockouts. So for blockout on those piers, how wide were they? What's the dimension of that? Is that on there? It's not going to be more than 200 mil. So if we say per pier, let's work this out. So same labour resourcing, but we'll say the blockouts are a bit more fidgety. So we say you do 4 blockouts per hour. So one every 15 minutes. They're 200 mil around. That means you need, still use LVLs, but you're going to need per blockout, you're going to need 4 lengths by 0.2. So 0.8. And that gives us a rate of $12.59 per blockout, so $700 to do all of them. Well, that productivity is probably a pretty aggressive assumption. We'll say 2 blockouts per hour. So that gives us $21.19 per hour. Steel fixing, so supply and install the Rio. So what are we going to need? This is just going to be a steel fixer. So rename that to a steel fixer. We'll say they're paid $30 an hour, assuming the same on costing. percentage, and we'll just call that steel fixer. Crew type is going to be, pull out 3, and I'll just, that's going to be that one. Put that in the pricing model that we need. Steel fixer. Good. That formula is just going to be fixed up. Now, the steel fixing, we need a production rate. So if we're basing this on meters squared, what do we say? So there's the slabs. There's 493 meters squared in the footings, and 12,000 meters squared in the slab. And if we assume, say standard for placing something like mesh, we just assume 25 meters squared per hour, so we need 0.04 of an hour per meter squared. And the mesh, we'll say we got a SL81, SL92, SL81 steel mesh, and then we got a quote of $20 per meter squared. And this is a bit bigger, so it's 24 per meter squared. That is probably pretty, we'll say 20 meters squared per man hour. So someone can place 20 meters squared per man hour, and it's going to be the same resource code for this. But they're going to need consumables as well. So we'll call those bar chairs, and we'll say $2 per meter squared. That's the little plastic things that hold up the mesh. Okay, so you get those. We've got the bar chairs as well. So just add in another line. I'm just going to copy that. This is just going to be 1. And we've got SL81, and then BC, which stands for bar chairs. And we're going to need each meter squared. So what's that coming out at? Should drag that down. Make sure that's summing correctly. It's about $24 a meter squared. And we can see the bulk of that cost is materials. That's 300,000. This is going to be the same. Just copy those down. Delete the subcontract costs. And then it's at $24 a meter squared for the steel fixings. That gets us up to 300 grand. And I just realized in this, I'd actually fully missed concrete. It's the spline installed to concrete, which is embarrassing. Call this concrete placement. Okay, so I'll just fix up the names of these. This will be footings. That'll be slab. Very supply and install concrete. Supply and install concrete. Resource requirements will be labor. So these concrete footings, they're all a lot of small individual footings. So if we say there's 56 footings and 56 individual footings, and each one is around 2 meters cubed, then you could make an assumption that in a shift, 2 concreters could do 5 footings. And they'd be able to do this from a They don't need a concrete pump or anything. They just be able to do this directly from a concrete truck. Actually, we'll make that 3 concreters and do 5 footings, and you only use concrete materials we're going to need. So let's quickly put these in. So the labour will be, call this crew 4, which will be concrete. Call that 3 by the labourers. Times 3. Top 4. Just going to fix that formula. So crew type 4, then just add in the quantity. So we said per footing 56, so that's meters cubed per footing, and then we're saying they can do 5 per shift. They do 5 per shift, that's 13 meters cubed. Yeah, meters cubed. It's 13.2 meters cubed per shift. It's about equals 10. So it equals 13 divided by 10. That equals 10 divided by 13. So 0.7 of an hour per cube. Plant, we don't need anything because we don't need a concrete pump, and then materials, we need concrete. We'll say 32 MPa concrete, and we'll say it's $100 per meter cube. But again, in reality, you'd have to get rates from suppliers. Cork. Book. That formula's got issue. So at $150 per meter cubed, supply and install. Then for the slab, I'm going to have to go add in the concrete pump, $240 an hour. We'll say we got our labour. And for the concrete placement, we said it's 2,000 meters cubed. Remember, we broke it up into we broke up the pours based on the construction joints. Like this. Yes, there's going to be 1, 2, 3, 4, 12 separate pours. So each pour is going to be about 100 cubed. So if we say 12 pours, 12 concreters per pour, and 12 pours, 12 concreters per pour, and a burn pump. So you put that in. You have 12 pours, 12 concreters at 10 hours. So that's 1,400 man hours, which equates to 0.75 man hours per meter cubed. So we'll put that in here. 0.75. We add in pump. We're saying for the pump total, it's going to be total is going to be 1920 divided by 120. So it's 120 divided by 120. We'd add in the concrete. There was a mistake. I was in 1. Delete the subcontract costs. That's it. We have about $192 per meter cubed. Now I just have to finish off the saw cutting. The saw cutting was 1540 meters. And dowels was 620 meters. So saw cutting, we just use a subcontract rate. Saw cutting. I killed it. So $61,000 for the saw cutting, and for the supply and install dowels, we're just going to need labour to install, and we'll say 0.25 man hours per dowel. And the dowels are 300 millimeter center to center. So we say is our labour. We just use the crew type of a single labourer. Right, it's going to be this, and the number of hours per meter is going to be number of man hours. We then need to convert it into man hours per meter. So we've got let's make this just, let's say 250 mil center to center for the dowels. It's going to be 1 man hour per meter, and that's it. That gives us, let's make sure this is signed correctly, which it's not. This up. The formulas in the spreadsheet aren't adaptable, You just have to double check them. Everything's summing correctly. Gives us 814 grand. So then we summarize this. So direct costs, 815. So we make this our direct costs. Then we need to add risk and opportunity. So the easiest way to add risk and opportunity is to make it really simple, we say 5% cost. So that covers things like wet weather, escalation. The last thing we need to add is indirects. So we've only been asked to provide project management. So if we just say, this is where we need to know the duration of the program. So project management, if we just make a high level assumption that it's going to be, there's 12 pours for the main slab plus the footing. So we'll say a 14-week program. So we say project managers, $3,000 a week. And the program is 14 weeks. And project management, we're just going to need 3,000 plus 14. Maybe we need a vehicle / ute. So we say $500 per week for that. It's going to give us. Need to get deliveries, materials, the excavator to site. So we'll call deliveries. We'll say $2,000 for floating machinery. Project management, vehicles, deliveries, and also any site inductions. We say 20 people at 1 hour. So it's going to be 20 man hours. So 20 by 35. $700. This gives us total costs, indirect plus direct. And the risk, that, and we say margin, say 15%. There we've got it. There we've got our sell price of $1 million. And that's what we've done. We've gone through, reviewed the drawings, entered all our labour, plant, material and subcontract rates, set up the pricing model, individually calculated the costs for each activity, sum these together to get our total direct costs, and then added on risk and opportunity, put in some indirect costs, added on our profit margin, and then we've got $1 million to do the concrete slabs of the warehouse.